Okay, you got a paper that's due today. Please make sure your names are on it. We're not going to spend a whole lot of time on this. I'll staple them. Okay. Okay. So tomorrow we've got. It really should say part 1 and part 2 because part 1 is naming and part 2, all right, is that of your reactions, which isn't necessarily going to be on. Oh, wait a minute. I'm looking at the wrong day. Okay. Review naming today. Review again tomorrow. Okay. That's what I had scheduled for this week. We're still going to look at a couple examples up on the board and then see once where we're at this time tomorrow. Okay. Thought I only had 4. But there's 5 there. So, how many common names are there? No. 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 Count in your head. I don't know. And I could be wrong, but I believe there is 4. Benzoic acid. Okay? So yes, those are your 4. And not that we learn them in a specific order, but I believe you had said phenol, toluene, aniline, and benzoic acid. That's right. Now, when it comes to naming these compounds, okay, why is it that can that bottom one use a 1-letter abbreviation? You are correct when you say no. Why can't that bottom one utilize the 1-letter abbreviation like the previous 2? Correct. But on the other side, does this bottom one have a common name? Yes, it does. Aniline, that's right. Okay, so that can be utilizing a common name. Okay, notice this one does not, this one does. Here you can use an abbreviation, but this one you cannot because it's got 3 derivatives on there. But it does have a common name. All right. Correct. But you can't use a common name, that's all, because it doesn't have one. We're talking about this one, right? Okay, but you can use this because there is only 2 and they are of the same type. I mean, okay, so you can still name them how you would want to because I'm willing to bet that as you would approach this, which is fine, and you probably did that on your paper, and you're still going to be right. If you had to draw this, we know we've got benzene. Okay. So what does a para position mean? What are the numbers? Something 4 is one of them. Right. So what you could do is if you actually had this on here, if this was on your paper, and if you had to name that, you could say we've got 1,4 dinitrobenzene. Okay, I think maybe we're getting the two mixed together between this and the common name, but there's nothing wrong with doing this. If you like the numbers better, that's fine. Okay, but you can also do that, because when you say that and there's only 2 derivatives, even if there isn't a common name, you can go ahead and use that 1-letter abbreviation. Okay, so what is let's say this was meta-dinitrophenol. We can go ahead and keep this nitro group here, or excuse me, if we had meta-dinitrobenzene, where would this nitro group go? One to the right or left, so it's either got to be in this position or this one. Okay, then you would have, yes, your meta position. Okay, for, oh, that's not till later. Oh, you mean what's in front of you now? Oh, okay. Well, let's wrap this up quick. All right. So that takes care of this one. Okay. Is this a common name? Yes, it is. Okay. So what is this telling you then? That somewhere there is a what? And when you draw these, I would just suggest put them up here. That's the simplest. So now we've got our phenol. And what is an ethyl group? And finally, where does it go? Up here? Okay. Okay. Yep. There is your meta-ethylphenol. And if you would rather do this, okay, it's also 1,3. Same thing. All right, this one does have a common name. So what is the common name for this one? And you said aniline, that's right. Okay. And we can't use our letter abbreviations of O, M, and P. POM, MOP, OPM. Yeah. So we can't mop this up. Not going to mop it up? No? We're trying to clean this up with a mop, but we can't because it has 3 derivatives, meta, ortho, or para. Those you see, you're going to mop things up. But yeah, that was bad. Okay, we're not in a good mood today. Okay, so let's keep moving forward then. Okay, so here's our aniline. You got 2 other derivatives branching off of there. What are they? You have a chloral group and a tertiary butyl. Okay, so if you like doing this, just so you know where we're at alphabetically, which one comes first? Okay, and because this is a prefix, right? So this one's actually going to come first. So what's the number on that T-butyl? Okay. Okay. You probably thought I started way too far over here. Maybe not. I don't know. Because it always takes more room than what you think. Does that look right? Looks right to me. All right, fair enough. So middle, good. Left side, right side, right side. Okay. Okay, what do we got? I just want to grab the same paper, so you said number 9. Okay. So with that, okay, that's an oxidation reaction I see. And one of the things that I think that works the best is when you see that reaction, and whether we do or don't like that flow chart, maybe yes, maybe no, I think it's really going to be difficult without it. Okay? Now, if you have that chart, okay, do you see something where you would see something along the lines of KMNO4 or K2CR207? We said this is an exception to the rule. It kind of doesn't like to follow anything else. So this is kind of off on its own. It's a special type of reaction. It's the one at the very top, okay? So on that flow chart, what does it illustrate? Okay, it's going to have your benzene ring, and then let's just say, for instance, it has R, double R. It doesn't matter how many that you have on there, or it doesn't have to be a double bond either. It doesn't matter how many alkyl groups you have on there or carbon and hydrogens you have on there. What's going to take place is when this oxidizes, okay, and in this case you've got KMNO4. I think you have some heat.
Are the R's just representing carbon?
Yes, that is correct. R is just a variable, okay? So then we've got some of this. No matter how many carbons are on here, okay, each and every one of them is going to get broken, and you're always going to form the same product. What does it illustrate? It's always going to be the same product over and over and over. Does it tell you? On your chart? Yes, I'm talking about on your chart there. What is that illustrating? Carbon with a double bond and oxygen. Yes, that's how you make benzoic acid. That's right. So we got OH up here and a double bond and oxygen there. Wouldn't matter if you had benzoic acid. And even if you had an isopropyl group. Oops, you went the wrong way. I suppose they didn't have to erase all of that. Same thing, benzoic acid.
And then you don't keep the CH2CH3?
No, nope, those just get broken and benzoic acid is formed. That's why he's kind of off on his own. Doesn't like to play by the rules. Call them renegades, I think. I don't know. Just sounded good at the time. Just trying to lighten the mood in here. It's Tuesday. Yay. It's not Monday. The sun's out. Yay. That is true. No one would argue with that. That is correct. Yep. Okay, number 12 and number 5 are very similar. Okay. So we'll just do number 12, and then number 5, like I said, is very similar. Notice you're not reacting. Oops, I was just going to say you don't have benzene on there. Okay. And in this case, okay, this will hopefully make more sense of this. So notice that what is it that's on the outside of this ring structure all the way around? Hydrogens. So why is it that there's 2 hydrogens on here and here, but only 1 on these other 4? Because we've got a double bond on the inside. And what that means is, do these aromatics, do they have to have a catalyst to react? There's double bonds in there. Yes, they do. So as far as stability is concerned, which one would you guess is more stable, the top or the bottom one? The top is way more stable. And just like when you did aliphatic hydrocarbons, which meant this, these are your aliphatics, does this need a catalyst to react? Do you think? It's a lot to remember. Does this need a catalyst? No, it does not, because this is highly, highly unstable. So for the same reason, this also does not need a catalyst. And I don't think there's one there. No. So then all that happens, I understand you're going to say, well, there's only 2 chlorine atoms here. But there's a lot of chlorine probably involved. So what we see happening here is this, oops. That is still there, okay? And then and wherever these double bonds are, see a chlorine, chlorine, and a chlorine, and a chlorine. Okay? That's all you just, wherever those double bonds were, like here and here, okay, that's where you attach your chlorine atoms. That's all you're doing. That's correct. Yep. And that's the same thing for number 5 as well. I understand you can say, well, how come you got 4 chlorine atoms here? Well, that when you only have 2. Well, we're not balancing this chemical reaction like you did in general chemistry. What you can do is just go ahead and put them on there. Okay? Yes, it doesn't matter if there's one alkyl group there or if there's 10. Each and every one of them bonds is going to break and get oxidized. Because one of the aspects that when organic chemists work on these reactions, they're not concerned with balancing these reactions and what's left over. They're just more so concerned about what is the major product. Okay. These papers will not be due tomorrow because I don't think you're going to get them done. Okay. And with an event going on tonight, I don't want you staying up till midnight to get that done just because we put a due date on that. Okay. One last thing I want to go over is on your chart there, okay, the lower left-hand corner, I think, right here, it's missing. Remember, what type of directives are halogens? From up here. Okay, so that's ortho position. It got cut off on the printer. So where's the para position for that R? Right across from it, yep. Potential spam. Okay. Yes, that is correct. On your flow chart, the copier just cuts that off, okay? Because what you see happening here is where you should have something like if R is here, X is there, that's the ortho position, and then we also know that it's got a para position then as well. That's the lower left-hand corner. It just got cut off on the printer. Okay. Were we able to tackle number 7? Okay. How is 7 unique from each and every other different problem on there? Because normally when we look at those types of reactions, okay, like 7 does, you have an alkyl group, you have toluene, and typically when you add a halogen, you would normally get 2 products, but this you do not. And we explained in the video, but can you remember in a video on why that's the case? If you can answer this, you are way ahead of the game. I want you to just think about that for a moment. The clue is on there, and I understand, we're not college students yet, we're not organic chemists, we're just trying to make you maybe take a couple steps back and see if we can jar your memory. Just look at the reaction and see if you can find something similar to that. You only get 1 product on there. Why are we not getting 2? Again, we're just trying to probe your mind and making you think. We're not going to penalize you or punish you if we can't remember. I just want you to think about it for a couple moments. It does help, yes.
But I thought if you had a CH3 on there, you would have 2 products.
You would. but this reaction's unique. And the clue is in the reaction. Is that a general consensus? Okay, so remember where we put these ortho and pair directors on there? We made you make that correction. Isn't there kind of like a detour here pointing in that direction? And what does it say under that arrow? Heat. Heat will do something altogether different in these reactions as opposed to a catalyst. Because every other reaction you would see, it's going to be a metal halide. Nickel, Cl3. Fe, Cl3. Maybe chromium and AlCl3, or excuse me, chromium and Cl3, AlCl3. Those are all metal halides. When it comes to adding with heat, it doesn't follow this part. It takes a detour and goes in this direction. Okay, so for in number 7, and this is where we said, if you remember from that video now, don't do this. Do we kind of remember this now? This would be incorrect. Can anyone think they can tell me why that would be wrong? And that was, and I understand, this was way back last Thursday. What type of formula, I understand it's methyl chloride, but what type of formula is this? Going back to like the first week of school we had here. This is a molecular formula. We said you can always help yourself out and write it in what type instead? The structural formula, okay? So let's look at the structural formula. So if you had that, okay, here's your benzene ring here. Okay, so there's one bond like there is here. Then you're saying you got 3, 1, 2, 3. Well, where's that chlorine? We can't put that down there. Why is that incorrect? Because you got 5 on there. You can't do that. Okay, so this is one of them examples where in the directions it says some of them are substitutions and others are additions. This is a substitution. So what you would need to do is either write CH2Cl or do that instead. CH2Cl. All right. I think that's probably enough for today. Okay? Because no one's going to lie. You're sitting in here and there's a lot going on. I know that. I get it. Our heads are maybe spinning. This is hard stuff. There's a lot to remember. But again, how many of you in your sort of career paths, you may be taking this again? To me, not you. This? I don't think you need this for your career path. Do you? Well, maybe you do. Okay, it could be. Oh. Okay. That surprises me. Okay, and I'm not an expert in that, and I'm not an expert in this either. But when you're going into that sort of program, we hope that you are 5 steps ahead of everybody else having to go through this for the first time. Okay? So again, we've got about 11 minutes left. Take the rest of the hour off, that's fine. Okay? I don't blame you, okay? Because this is hard stuff. Wrap your head around this stuff is difficult. If we're struggling with it, that's where we're here to help you. Just like maybe last night was a little frustrating, but when something's not going right, good teammates raise everybody else up. And we've said that before, okay? And there's no reason that that did or didn't happen. I don't know. I don't know a lot about volleyball, but hey, it's in the win column. All right. So that's all I've got. We'll catch up to you next time.